Okay, so now I'm going to guide you through a problem without doing the work for you, but I'll guide you through the ideas of how to solve a system of three linear equations using elimination and back substitution. So the problem that we will try to solve is as follows. So the first equation of the system does not have an x, so leave a space for that. Then we have y minus 3z equals negative 5. The second equation is 2x plus 3y minus z equals 7. And last we have 4x plus 5y minus 2z equals 10. Remember to make sure to line your x column, y column, and z columns up. That visual effect can help you as you're working through this sort of lengthy, tedious problem. Okay, so the first thing we want to do is get this system into the right format so that we can do back substitution. And so that's where you eliminate certain variables. We want all of this stuff to go away. But the problem is there's no x term in the first equation. So how do we handle that? Well, this can happen, and one of the easiest things to do is just simply reorder your equations. So what I would do is move this equation to the third row. So let's rewrite our system. And like I said, this is tedious, but necessary. So maybe move the second row up to the first. So 2x plus 3y minus z equals 7. Then 4x plus 5y minus 2z equals 10. And then y minus 3z equals negative 5. And so now we don't have to eliminate this guy because he's already gone. Okay? So just reordering your equations is a valid technique for solving a system. They're still the same equations. It's still the same system. So now to get started, this is where the work comes in. What you want to do is you want to start doing row operations, and you work by columns. So you start in the x column, and we need this 4x to go away, right? We need the 4x, and we're going to need this y to go away eventually. So what we do is we work on the x's first. So we're going to take, and we want to use this 2x from row 1 to eliminate the 4x from row 2. Okay, and I'm going to help get you started here. We want those to be the same number, but one negative and one positive. So I'm going to tell you that I want you to take negative 2, write this out, negative 2 times row 1, that's going to change this 2 into negative 4, and then add it to the row 2, so the negative 4 and the positive 4 will cancel. Of course, everything else from those rows is going to change also. But that's going to give you your new row 2, because that's what you're trying to do, is rewrite a better version of this row 2. So go ahead and work out the details. Multiply both sides of row 1 by negative 2 and write that out here. Plus, copy row 2, write that out here. Add those together. The x terms should cancel. And then you'll get y, z, and some constant over here, okay? So you should get that. Pause and work on it and see what you get. Now, if both sides are divisible by some number, go ahead and divide both sides by that number to shrink these values down, and that's going to be your new row 2. We don't have to do anything to row 3 because this guy's already gone. So we don't have to do anything. That's less work for us. So now what we want to do is rewrite our system. So row 1 doesn't change. Row 2 does change. So put in here what you got for row 2. There should be a hole here where the x term was. And then row 3 didn't change. We didn't get a new row 3. So let's copy that down also. Okay? Alright, so that's your new system that you're working with. All the x's below the first row are gone. That's good. The next thing we need to do is move over to the y column. Now when you're working on the Y column, you don't use row 1 anymore because row 1 has an X. You don't want to mess with that X anymore. That's good. So now you move down to row 2 and you use the Y term from row 2 to eliminate the Y term from row 3. So what I want you to do is figure out how to make those two Y terms have the same coefficient, but one positive and one negative. So you're going to have some number times row 2 plus maybe some number times row 3. Those can be 1s, by the way, if that's what's necessary. And you want to replace row 3, so you're going to get a new row 3. Okay? So figure out what you need to multiply row 2 by, and then write that out after you multiply it, and then add it to what you get after you multiply row 3. Add those together, and what should happen is the Y terms should cancel, and all that should remain is some Z term equals some number. And that's going to be your new row 3. Okay? So again, pick coefficients here so that when you multiply and add, the Y's cancel. That's the goal here. Now, if both sides of this Z equation are divisible by some common factor, go ahead and divide to make the number smaller. But this is going to be your new row 3. So now, recopy your system. So row 1 didn't change. Row 2 didn't change. It still has Y and Z. But now row 3, so your row 2 is still the same as it was up here. But now row 3 is going to have just a Z equation. Okay? And so your system is in the right form. You've got this nice stair-step effect now. The last equation just has Z. The second equation has just Y and Z. And the first equation has X, Y, and Z. Okay? So now what you need to do is solve. So you take the third equation and solve it for Z. See what you get. Solve it for Z. Z equals what? Okay, figure out what Z is. And then once you know what Z is, copy the second equation, which should have Y and Z, and take the Z value you got before and plug it in, and then solve this equation for Y. And now you should have your Y value. Okay? Again, pause and work on this as you need to. Once you know Z and Y, take your first equation, which I can write down because that was given to us. It never changed. And then you're going to plug your Z value in that you know, and you're going to plug your Y value in that you already know, and you're going to solve for X. Once you know your X, Y, and Z, write your answer as an ordered triple. Okay? So pause and keep working on this, rewind as you need to, and see if you can figure out X, Y, and Z, put them into an ordered triple, and when you come back, I'll give you the answer that you can check with yours. So the correct answer is the ordered triple, -1, 4, 3. That ordered triple makes all three of the original equations true. Now if you didn't get that, if you were very organized and showed all your row operations, you should be able to backtrack and see if you missed a negative, if you multiplied wrong, if you added something wrong, and see if you can find any errors that you can correct to come up with this correct answer, -1, 4, 3.